Welcome back everyone to the brand new episode of the Code Drop, and today we're going to continue with our data structures and see how to make queues using array. So queue is a linear data structure where the first element is inserted from one end called rear and deleted from the other end called front. So it basically works on the principle of first come first serve. So the element which is entered first is the element which gets deleted first, instead of stack where the first element to be inserted is the last element to be deleted. So there are two ways using which we can make queues using arrays. So let's just look at the two ways using which we can make queues in an array. To explain it better, I have opened this Excel workbook and I'll be showing both of these methods here itself. So let's just say this is method 1, and let's say our queue size is of 4. Now what happens in queue is, let's just assume that this is the first place, so A7 is going to be our first element, and that is where our first element gets stored. So 1 gets stored there. Now the second place will be B7, and our second element gets stored in B7. So let's just say 3, and then again C7 will have 5 and D7 will have 7. Now once we have done this, our queue is full. So once the queue is full, before inserting any more elements, we need to delete the first element. Now there are two ways to do this. This is a specific place where there are the two methods separate, and the methods are first using positions. So what you can do is you can just shift the position from the first. So what you can do is you can just shift the first element's position from A7 to B7. What that means is we'll just ignore whatever there is in A7 and we'll assume that our index starts from B7. So if we do that, we'll again have 3 elements here, and then we can store our fourth element in E7. So fourth element, let's just say it's 9, and it gets inserted here. Again, if you want to delete something, we'll just ignore B7, we'll just remove that index and shift our index now to C7. Again, we have 3 elements, and we'll include our fourth element in F of 7. So let's just delete this because these are related. Now this is one way to do that, and mostly you're going to see this method. This is highly inefficient because to implement queue in this method, you need to have an array of unlimited size, and main objective of data structures is to decrease the memory allocated to a program. So this is not an efficient way to do that. Now the method I use, and which is actually efficient, is this way. So I'll just say this is method 1, ignoring shifting index. Let's just say this is called shifting indexes. Okay, and now this is my method, which is method 2. Well, this can also be found in the wild, but I haven't seen anything like this, and it's super rare to find this program. So this is just what I can say, method 2, and this method is called shifting elements. So again, I'm going to use the same example, 1 3 5 7 9 8. Now first of all, we'll insert our first element in 1, which is A11 here, and then our second element in B11, third element in C11, and fourth element in D11. Now our queue is full, and what we want to do is we want to insert a new element. So before inserting, we need to delete. If we insert any more element, it won't be it won't get stored. Like, it will get stored here because we're using an Excel sheet, but when we're writing a C program, it won't get stored because the queue is full. So let me just replace it again with 4. And now what we do in this method is we copy all the next elements in the previous elements. Now what I want to say is that we'll copy the element in next index and shift it to the current index. So in our index 0 we'll have 2 instead of 1. In our index 1 we'll have 3. In our index 2 we'll have 4, and in our index 4 we'll have 0. So we just want to keep it 0 because we're not entering any element 0. And the advantage of this is we are not going anywhere else. We are just using the 4 values. The size of our array doesn't change. It is highly efficient. Now the only drawback with this method which I can see right now is that I'll have to loop through the elements, and it should not matter because even if we use a loop, the time efficiency will still be O of n, nothing more than that. So it's highly efficient still. Now to get a gist of what I'm saying, we'll just write a C program and we'll try to implement method 2 using C programming language. Now before we start writing the code, I just want to say that please subscribe to the channel because there will be a lot more of data structure videos coming in the next few weeks, and you really would not like to miss out because we'll be covering linked lists, we'll be covering application of queues, and we'll actually be covering how to make queues and stacks using linked lists, not just arrays but also using linked lists. So if you want to know all that, you can just subscribe to the channel, it helps a lot. And let's start with our code now. So let's shift to our dev C++ console here and let's make a new file. And first of all, I'm just going to include stdio.h, and I can see that the font size is a little bit too hard to see, so it might just be enough. Okay, and then we're just going to define a size. Let's define a size of, let's say, 5. Okay, right there. And then what I'm going to do is I'm going to say make a queue, and I'm just going to say queue of size right here. Now again, like our stack, our queue is a global declared array, and it's going to be really handy because we'll be using different functions here, and it's just easy to operate on global variables rather than passing through in functions and then keeping record of them. That just makes the task a lot more harder. Okay, so now we have to find our queue, and first of all I'm going to go with main function because that's what our drive program is. And we'll be requiring 3 functions here. The first is called enqueue. So first let me just take an input for any number. Let's say I'm taking an int n, and let's say I'm taking input for that, so mod d and n. And what I'm going to do is I'm going to enqueue it, enqueue n. Now there are 3 main functions in queues. The first is enqueue, where we insert our elements in queue. Then we have dequeue, where we remove our element from queue, and then we have print, which prints the current queue status. So what elements are there in the queue right now? Now first of all we're going to make our enqueue function right here. So let's just say void enqueue because we don't need to return anything as it's a globally declared variable. Our queue is globally declared, so let's just pass int a here. And the first thing which we want to do is we want to check if our position is greater than size minus 1. So we haven't defined our position, right? Let's just say that we have another element which stores the position and the value starts from 0 so that we can keep increasing the values. So what I'm going to do is if position is greater than size minus 1, then we want to print queue is full, couldn't insert element. Okay, now this was our first case, and if it is not the case, what we're going to do is we're going to say that queue of pause, so it's capital Q of pause equals a, and then we're going to say printf /n element mod d was inserted in or at position mod d. So first of all I'm going to print a, which is the element which is inserted, and the position is pause, and then we'll say pause plus plus. Now what we are doing in this enqueue function is we're first checking if the size of queue is less than is equal to size of queue itself or not, if the position is equal to size or not. If it's equal, we can't insert the element because our queue is full. If it is not, we'll insert our element, we'll save a in queue of position, and then we'll increase the position size so it's easier to manage that. Now we are just using one variable pause. If we were going to with the if we were to go with the first method actually, the first method will have only will had two elements, which will be rear and front. So it's easier this way. I think it's easier to manage the code right here. Now this was our enqueue function. Next, what I'm doing is I'm going to say I want to print, or let's just enqueue one more element. So let's take another input. Let's take another input for scanf mod d and n, and again I'm going to enqueue this element n. Now after that I want to print my queue. So let's just say print queue function, and it does not need any parameters. And what print queue function is going to do is it's just going to print our loop. So void print queue, and we'll just have integer I and a simple for loop for I equals to 0, I less than n, and whether I less than size, is it capital size? Yeah, it's small size. I less than size, oh sorry, I plus plus, and then we're just going to print our queue. So printf mod d and comma space comma, our second parameter is going to be queue of I. This is going to print our queue, and after it's all done we'll just add one more slash in here so that we have some clear output in our perspective. And let's just add one more slash in here too. Now these are our two methods already done. Now the third method which remains is called dequeue, and what dequeue does is it just removes the first element and empties the last index so that another element can be stored there. So let's just make a dequeue function right here, and dequeue function does not require any parameters because we just want to remove the first element. And now let's write our dequeue function. Let's write our dequeue function just below our enqueue function. So it's going to be void dequeue. Pardon me if the spellings are wrong. It's just a matter of understanding the program, not the spellings. So pause equals less than 0. Okay, so if position is less than equal to 0, this means that our queue is empty and there's nothing to remove. So we'll just say queue is empty and nothing to be removed. And there is, let's just say queue is empty comma nothing to be removed, and we'll add an apostrophe right here in our statement. If this is not the case, then first of all I'm going to take an int I, and I'm going to run a for loop for I equals to 0, I less than n, I plus plus, and it should be not I less than n, it should be I size minus 1 because we're working with size here, not n. And what I'm going to do is I'm going to say q of I equals q of I plus 1. So this is the function where we are shifting the elements to the previous indexes, and at last we'll say q of size minus 1 should be equal to 0, or rather it should be q of pause. I guess q of pause should be equal to 0, right? And then we're going to say pause minus minus because we want to decrease our position too. And I think this is our program right here, and now we'll just run this program, and it says okay, yeah, we had to use capital Q not small q right here, and let's just hope it's correct now. And I'll make a few changes here so that it's more of a choice based thing rather than just adding more scanf and printf functions. And then okay, do we have time here? No. Well, then I guess just we'll have to add a speed run of what I was going to do in the video and make the video shorter, I guess. So let's just cue the speed run thing and let's run a music in the background. Okay, and I have made all the changes, and I'll be linking this program. So we just want to see the output of our current program, right? So let's just see what happens. And this is the output we get once we run this program. And let's just see what we can do with this program. So first of all, we have got four choices: insertion, deletion, status, exit. So let's go for insertion, and the first element which I'll be inserting is 4, and 4 was inserted to position 0. So again, let's ask for my choice. I'll say insert one more element, and let's say insert 7. Now I'll print my status. So my status is 47000. Now what I want to do is I want to delete the first element, and it says the element from at last position was dequeued, so it should be first position. I made just a printing mistake right there. You can see at this corner of the screen, right? Now what I'm going to say is I'm going to say that print the status, and we see that 4 has been removed because it was the first element we inserted. And let's just insert one more element, and let's say we insert 9. We print our status and we get 79. So the program works fine, and just to make sure, I'll just insert a few more elements right there, and I'll now insert 7, and at last I'll insert 2. So when we insert 2, you can see that queue is full, couldn't insert element. This is the error we get. And just to confirm that, we'll just print status of our queue, and we say that our queue is actually full. So we have 79467 in our queue already, so we can insert any more element. Now since we have completed a program, well, we just exit this and we get back to our program. So this was pretty simple. I've just added a few else if conditions and a while loop so that the loops get run infinitely, nothing else. And I'll just link the source code of this program right in the description, and you can check it out from there. So this is an efficient method, I would say, to use queues using arrays in C, or in that case any other programming language you like. And that will be the end of this video. Thumbs up if you like the video and subscribe to the channel if you loved it. I'll see you on the next episode of the Code Drop. Bye for now.